our first webinar in the fall winter series of webinars for the Wildlife Viewing and Nature Tourism Working Group of the Association of Fish and Wildlife Agencies. My name is Shelley Plant. I'm the chair of the Wildlife Viewing and Nature Tourism Working Group. We're going to ask that you all keep your sound muted while on the webinar, just to make it easier to understand and to help. Because we are recording this webinar, we will have it available on the Wildlife Viewing YouTube channel for the Association of Fish and Wildlife Agencies after the webinar is complete. And we will, if you have questions, just please put them in the chat. And Anne Glick in Florida and myself and Patty Allen from AFLA are going to be watching chat to see if any questions need to be answered right away. There is a natural break partway through the presentation, so if there's a time-sensitive question, we'll try to ask it then. Otherwise, we'll get to them all that we can at the end of this webinar. And with that, I'm going to pass it to Mark Dittmer with U.S. Forest Service. Thanks for joining us today and sharing your knowledge.
Hi, thank you so much. Thanks for having me, and thanks to all of you for tuning in. I'm excited to share some ongoing research with you today. I'm going to share my screen and share audio as well, with the hopes that you'll all be able to hear some of the videos that I have embedded. Okay. All right, so topic today is using smartphone GPS locations to track increased visitation and minimize impacts on wildlife. I'm Mark Dittmer with the Rocky Mountain Research Station, and I am currently in Fort Collins, Colorado. So, as you're probably all very aware, we've seen a large increase in public land use, starting with really exploding during the pandemic, but it's been a long-term increase. And as a result, places such as Arches National Park, Glacier National Park have implemented these timed entries to limit the amount of people, visitors during certain times and places throughout the parks. And so it's really become a pressing issue to understand where are recreation hotspots, how is it impacting our wildlife on public land. However, our national forest system is even larger than the national park system, and I'm going to be focused today on the Bridger-Teton National Forest for many of my examples and some of the national parks around there. The reason being is Bridger-Teton is also inundated with a lot of recreation use, and they're going through a forest revision plan. So they're trying to sort out what are the best ways to improve management moving forward as they develop this plan. And we'll zoom in here, the area we're talking about. So if you're unfamiliar, Bridger-Teton National Forest is actually larger than Yellowstone and Grand Teton National Parks, and it's just to the south, highlighted here. And you know, as I mentioned, we've had all this pandemic-related increase in public land use. Here on the right, you can see a bear jam in Yellowstone, but it's not limited to just those national parks, especially places like Bridger-Teton that are adjacent to them. There's a lot of spillover effect, and this increase in public land use has brought about a lot of questions. And unlike national parks, there's no gates to count people as they come into certain entry points. A lot of times, national forests are in basically people's backyards, and they can just walk into them anytime they want. There's a lot of dispersed camping, things like that. And in addition, there's a lot more diverse types of recreation that occur on our national forests, such as OHVs, which is certainly not allowed on most on national parks. Recreation throughout the year may be more abundant because of that lack of having to enter through a gate and things like that. Basically, a lot of trail systems right near residential areas, and so we have a lot of diverse type of use. And to try to get our heads around, where is this happening and when there's no real, set entry points other than a lot of, roadways throughout our national forests. It's become a real question for managers, not just in the Bridger-Teton, but throughout our national forest system, and of course, well beyond. So part of this is that question drove the Bridger-Teton to form a science team to help sort out how in the world are we going to get at some of these questions about recreation use and what types. And the part of this, and we're going to touch on it briefly and then return back to it later, is that it's not just simply the exact locations and how many people are using a given spot or a given trail. It's also the associated noise with the different types of recreation and the amount of recreation happening in those places. And, we actually have models for really the continental United States that estimate noise. However, these are, static extrapolations from the best models that we have, but really we lack that dynamic ability to understand changing recreation patterns and changes throughout the day. So even though we can predict these things based on things like roadways and all that, we're really lacking the dynamic component to understand that aspect of recreation use and its impacts on wildlife. And so this just kind of summarizes that, in that we have not only wildlife encountering recreationists, on the trails and their ability to actually see and interact with people, but we also have the associated bleeding into the environment of various recreation noises, and that's obviously going to vary quite a bit depending on the type of recreation we're talking about. And part of research that I've done in the past has been looking at sensory pollution and its impact on wildlife. And what you're seeing here is the continental United States, and the light values are actually remotely sensed estimates of artificial light at night. So the human component of light being captured from satellites, whereas the sound or the noise component here is this predicted models from the National Park Service, which are the best that we have, or include over 80 covariates of things that contribute to noise on the landscape, but again, not dynamic, and are snapshots for our best estimates. And so what you're seeing here is areas in purple are where we have areas of a lot of artificial light and a lot of noise. Blue is a lot of noise with minimal light, and yellow is a lot of light and minimal noise, whereas areas in gray are where we generally have both the minimal sensory pollution. We're going to return back to this idea, especially with the sound thing, as we move through this talk, but I just wanted to plant that seed in your head as we go forward here. So back to our main question here of step one, how do we figure out where people are going and how they're using the landscape? Well, we looked into a lot of different options and discussed at great length how to do this. We could obviously use some of the traditional tried and true methods that give us actual counts of people using the trail systems and whatnot. But obviously, it's very limited in that it's Bridger-Teton's a huge place. We'd have to put out a lot of these, and we're also missing then people that are off trail, and it's not necessarily going to tell us all that much about the type of use unless it's paired with cameras. So it's really kind of a limited and as to the scope of what you can capture with some of the more traditional efforts, whether it's trail counters or camera traps on trails. We also looked into utilizing data from applications that collect recreation use, such as Strava. However, this is pretty biased in terms of the types of recreation that's being done, and then even the socio-demographic groups that are going to be using Strava. It's going to give us a pretty biased estimate, and including the fact that this data is much more on lockdown in recent years because of a lot of different things that have gone on. So really, it wasn't that good of an option to just rely on certain applications that we think would be most useful. There's also the social media aspect where there have been a lot of good papers out there in previous years on recreation ecology utilizing social media, but again, rather biased, although it can give us a decent indices of use. However, that data is becoming more and more difficult to obtain and to use, especially at broad scales and in backcountry and for different types of use. So I decided to expand our what we could potentially utilize to capture this at such broad scales. But we also wanted to make it so that it wasn't just useful to the Bridger-Teton, but would be useful to all of the surrounding greater Yellowstone area and really all national forests and parks, so that we could have a standardized comparison of space use recreation hotspots across all of these areas. So to do that, I turned to looking at anonymized cell location data from smartphones, essentially the GPS locations that get collected. Now, before we get into what all this, the data set provides for this sort of work, just go over a little bit of background. A lot of these companies that purchase cell data from the different providers, it's completely anonymized data and compliant with various different consumer privacy standards. And the efforts we're doing here is going to be informed by best privacy practices for quote unquote big data. Basically it's obviously a sensitive thing to people, but we're hoping that through it being anonymized and following all the best guidelines for utilizing such data, that we can make this a viable option for especially National Forest System and beyond. So with this anonymized cell data, what does it really provide us with? Well, we get a timestamp and a location from every user, and that timestamp obviously is important for understanding the temporal aspect of where and when people are using the landscape, and as I said, the location, and that's based on the cell phone data's GPS internally. It's not from a cell phone tower, so the device itself is capturing the locations. And the one company that we worked with, and these values will range quite wildly depending on the company and the price. The company that we've been working with says that their data collects basically 10 to 15% of the US population of smartphone users in a given day. And importantly, as I mentioned, for backcountry use and for off-trail stuff, it doesn't rely on cell phone tower coverage. And essentially, your phone is constantly taking background GPS locations of your movements. And as long as a person comes in contact with a cell phone tower within 72 hours, that data will be uploaded and available with the company that we've been working with. That might vary depending on company to company. And really critically for the recreation component, each location is associated with a unique anonymized ID, so that we know then that all of these locations came from the same cell phone. So it allows us to create movement paths and get at movement rates of cell phones. And we'll see how that plays in a moment. Really importantly, this is, the data are available at a continental level, throughout the US and beyond. So it really allows for cross-boundary standardization. Now, I'm going to show you a few example maps moving forward, and I'll just mention that we haven't actually been able to fully purchase the data yet. We're currently working through that, but we were given a month's worth of data to work with. August of 2020, which was a rather big recreation month, especially with pandemic levels, according to a lot of the managers. And so what you're going to see is just kind of a really fine scale look at what is all possible. So here we're seeing the outline of the Bridger-Teton National Forest, and over the course of, it was about 2.5 days that I looked at here, we had over 180,000 cell phone locations within the boundaries of the National Forest itself, from over 5,000 unique cell phones. And we can convert these to, say, if we wanted to make daily heat maps so that recreation managers and wildlife biologists can understand really where people were the previous day, things like that are possible. But what's also interesting is that, here we're looking at the Wind River, a satellite image of the Wind River. It's a popular hiking area, and each of the colors represents a different user. So we're able to start to separate out the numbers of users and compare it against some of our traditional metrics of trail use, et cetera, et cetera. Here's another quick example, just because it's a little more dense of where people are. I wanted to show this. This is Grand-Teton National Park. And we see about a similar number of cell locations from those same days in August, but we have a lot more different unique cell phones as people kind of duck in and out of the park. And here we're seeing a popular campground. And again, the different colors represent different users. You can see a lot of different intensities of those locations, based on how quickly the person's moving and also how frequently the cell phone is capturing a GPS location. So if someone's using an app that really heavily relies on GPS, you're going to get a lot more locations per phone than someone that just, has their phone tucked away. Here's another quick example, just because it's another, important area within the region, the Lamar Valley, known for its wildlife. In Yellowstone, again, just a couple of days, and we have over 311 unique, this is one day, I'm sorry, 311 unique smartphones, and you can see some of the backcountry use there and a lot of the use along the road as people are watching for wildlife. But importantly, for really kind of digging in, what you're seeing here is the Grand Teton National Park cell phone data locations throughout that weekend. So we can begin to dive down and look at the space use through not only, at as fine of a level as we want. Here I summarized it by hour, but you can see people entering the park in the early morning hours, using the park throughout the afternoon, and really kind of spreading out, hiking up into the higher country, which is kind of there on the western side where the mountains really are. And then at night, leaving the park as it diminishes. Here we're just zooming in on it within Grand Teton, just one user. So here's someone hiking up to an alpine lake, and then there's their movement path during part of that hike. And this is, again, as I mentioned earlier, really important because now, by having this information, we have the movement rate between these locations. And if we look at all of the different users that were in Grand Teton during that weekend, here's a histogram of the speed that those smartphones were moving during that time period. And you can see there's a lot of people around zero, likely camping or at the gift shop or sleeping or whatever. But then you also have a lot that were using the highway, 60 miles an hour, et cetera, et cetera. And so thinking about how do we use this information in combination with other things to begin to separate out different recreation activities. Well, to do that, initially, and I hope to return to this as we kind of get further along with the analyses. There's a lot of different ways to think about this sort of problem. One of them that I do pretty regularly in the wildlife sphere. Most of my work is in spatial ecology. So here's an example from moose in Minnesota for a study that I did. So we have GPS locations of the moose, just like a cell phone location from a smartphone. And by looking at how fast the moose are moving in combination with the other metrics I'll show you in a moment, we're able to start to separate out different behaviors, whether it's resting, foraging, or traveling. So those locations from the collar give us the movement rate. But we can also look at the tortuosity. How is the animal moving through the landscape? How quickly, how much are they turning around? And that can tell us a lot also about sort of, are they meandering and foraging, or are they V-lining it from one spot to the next? That also helps to inform our classification of these different behaviors. And there's also accelerometry in the collar, and that also really informs us. So the activity level, so there's our travel state, obviously the most activity associated with that, all the way down to rest. So the more information we can glean and associate with our GPS locations and our movement, the better we can start to classify into different behaviors. And that's what we're going to do here with our cell phone data. So I took an example of 30,000 locations from a spot in the Bridger-Teton. And this is just a really basic approach of cluster analysis, where I haven't done a full hidden Markov model like I showed you with the moose, but just real basic, you can begin to start to separate out different recreation types. So here we have speed of the GPS locations as part of this classification attempt. So from location 1 to location 2, how fast did you move? Distance to trail is also incorporated, distance to highway, types of roadways, how far away you are from different campgrounds or picnic areas, whether you're in water or not, and the position of the sun. So really the time of day. So what recreation types are more likely in the evening versus midday versus at night. And by doing this, we're able to start to separate out most likely behaviors. And then you can see some examples there for this, real basic example. We have highway traffic, people that are associated with some of the nearby towns, hiking, boating, potential OHV use. So then there's always going to be some that don't neatly fit into categories that are, as we refine this model and refine this algorithm, we'll be able to classify use, better and better, and also compare it with some of that validated on the ground estimates as well. Now, importantly for me as, a wildlife ecologist, there's obviously a lot of great questions about recreation and how to best manage that, but there's also a lot of questions that I have about, how does recreation impact wildlife? So what you're seeing here is the GPS locations from 54 different collared mule deer on the Dixie National Forest in Utah over the course of 5 days in 2020 again. And each color is a different animal. And now what you'll see is all of the cell phone locations during those same 5 days in the same location. Now you see people using a town and a highway cutting through the national forest. But there's over 4,700 different smartphones that move through this area during that 5-day period. Now the question is, when are people interacting with wildlife? Where is their actual potential for direct human wildlife, either conflict or just however you'd want to define it? So what I did was I analyzed it in terms of what I called an interaction between one of our mule deer and a human with a smartphone. Is that I said, if the two locations, one from mule deer, one from a GPS location, came within 100 meters and 10 minutes of one another, I called it an interaction. But I can, set those thresholds at whatever I want based on how sensitive the species is, or et cetera, et cetera. And what I found over just that 5-day period, that there was over 35 actual direct interactions that meeting that threshold. And so remember, this is 10 to 15% of cell phone users. So multiply it by 8 to 10 times. And this is only 54 mule deer that happen to be collared in the areas. But it begins to allow us to start understanding and picking out where are those interactions happening. And that's what you're going to see here. So what you have here is 2 mule deer, blue and green here. They're moving by a town, the edge of a housing development at the edge of the national forest. And then when we overlay our black cell phone locations from people, we can see that not every GPS location from this animal and every cell phone location is associated with a close interaction between the two. But those spots in red, those red triangles, represent locations where that threshold was met, 10 minutes and 100 meters. So people are in the same place at the same time as our collared animals. So that's one aspect, that direct interactions and direct things, but we also can think about this at a much broader scale for wildlife, thinking about movement corridors, thinking about just sensitive habitat areas and where is our recreation hotspots and what types of recreation are going on in those. So we're not just limited to those direct interactions. We can think about the cell phone data as providing us with a really unique way to capture the dynamic human footprint as it moves across space. And obviously that movement across space is going to vary a lot by time, whether it's intradaily or seasonally, as people use different parts of the landscape, depending on weather conditions and everything else. So it opens up a lot of doors in terms of thinking about wildlife connectivity and everything beyond that as well. So to kind of wrap up this first section, we think that the cell phone data really provides us with a unique opportunity to improve in 3 major areas: understanding the dynamics of human recreation behavior, and we're able to assess the use and intensity at large scales, looking at the shifts pre and post, during, and hopefully post-pandemic off-trail use, the ability to develop predictive models of recreation for proactive management. And we can compare these values with some of the traditional things that are already out there and in place to see just how much do we have to alter our model to improve them further. Then, of course, what I'm most interested in is relationships between recreation and wildlife, quantifying that spatial and temporal overlap with different activities, critical wildlife, times of year and habitats, developing dynamic models of human space use for looking at wildlife connectivity. And we can also begin to think about quantifying thresholds of recreation where we start to see a response in wildlife. So we can, understand what are sort of the limits in certain areas for certain species. I think it provides us, a really good foundation for that sort of effort. And, in just more basic terms, management, efficiency, and monitoring, whether it's the effectiveness of, say, something like a seasonal closure, like blocking off a road because there is, say, grizzly bear activity up there. Well, we can see how many people actually obey those signs in those closed areas. Better allocation of staff efforts and resources, and really thinking about this idea of, for, areas that are supposed to be more have wilderness character. Where are these sensory pollutants from, certain types of recreation, et cetera, beyond what we would consider, this wilderness character? How does that allow us to help set some of our usage limits and our permits across broad scales? So yeah, before I dive into kind of the next piece, additional research that I'm doing to hopefully expand on that, I don't know if you wanted me to stop to take a couple questions, or if I should just take them at the end.
There are a couple of questions, and I think some of them you've answered already.
Okay.
But one has to do with how you acquired the data. But I'll start. The first ones were, does the data only include phones with location services turned on, or any cell phone pings?
Yeah, there's a lot of details about it. It's going to depend on the company, but like obviously if someone has airplane mode on, or obviously if their phone is turned off, it's not going to be taking locations. There are certainly ways that people are able to opt out of having their locations and all that stuff shared to third-party services. So that's potentially something that might limit our future use if more and more people opt out of having their locations shared and potentially sold for stuff like this. But yeah, but it captures, if your phone is on and you haven't completely opted out of all of those things, you're taking locations, and as long as eventually you hit a cell phone tower within, like I mentioned, 3 days for the case of this, that data will be uploaded and included if it's within that 10 to 15% of people that they purchase the data for. And they try to purchase the data so that it's across, there's no like super heavy geographical bias or anything like that.
Okay, and then you answered this one is, if you're a wildlife biologist, can you overlay cell data with radio collared animals, which you showed us examples of that. And then the last one is, how did you acquire the cell phone data, and is there a fee associated with it? I know you said you had about a month's worth of data and you're in negotiations for long term, but is there a simple answer to that question?
Not a simple one, but I'll just give you as quick of a rundown as I can. It's not free and it's not all that cheap, but the several companies do have data for good programs that they're willing to sell it basically at cost. And that's really the route we've been going, showing that, we're not using this for any sort of profit making, that it's for conservation purposes. And then, we're basically allowing the company to say, hey, look at what we did. And so that, and the pricing, it's really hard to say. It's going to depend on which company and what percentage of the cell phone locations and all of that. So some of them are able to sell it at a much finer spatial resolution if you don't want the whole country. For example, I had August for the whole country, which was, that is just terabytes upon terabytes per day of GPS location. So I had to develop code to really kind of filter it down first. But some places that are, maybe more expensive will pre-filter it for you.
And the last one's a comment, so I think we can save that till the end and let you get started on the next section and then go
Would,
back to questions.
would
Sure.
I be able to ask a quick question?
Okay.
Hi, Mark. Name's Antonio Garcia. So I saw that, in the data that you were doing, you were using your collared, deer and everything like that. So in order for, this to work, do you have to have certain wildlife that is collared? And if so, is there a formula that you use? So like during the rut, okay, you're going to have that one collared buck that will be around, a herd of so many does or something like that. So how do you figure out how much more wildlife it is affecting than that one collared animal?
Sure. Yeah. I mean, you're limited by, you don't necessarily, so what I was showing there with the GPS locations was just if you do have really any collared animals and you're interested in sort of responses to humans on the landscape, you can begin to look at questions like that, where you define whatever threshold for your animals and people. Now, obviously, you're going to be limited by the amount of animals that you have collared or whatever, and they're if they're in a super remote area, maybe they don't encounter any people. But it was just an example of looking at direct interactions. But really, where I be far beyond that, though, you can begin to overlay the intensity of use of different recreation types, or just people in general, over say certain habitat that you already have determined from whatever method you might have used. So there's really various ways it could be applied. Yeah.
Okay, thank you. Appreciate it.
Uh-huh. All right, so I talked a bit about that modeled sound component, but again, it's just really a snapshot developed, from an analysis by the National Park Service. And of course, I just went through the whole spiel about the cell phone data. But really, the cell phone data allows us to improve estimates of noise on the landscape by really incorporating that dynamic component when they can be related. But to kind of get at a more holistic approach of better management for both wildlife and people in our national forests and beyond, we also really have to think about wildlife sensitivity. So to recreation and to especially recreation noise, so bringing these pieces together. So I'm going to talk about a study that we launched this year, also on the Bridger-Teton, that kind of brings these ideas together. And we're actually utilizing some of the cell phone data to classify how the recreation use in where we're doing our sampling, so that we can understand how potentially habituated are the animals that are experiencing what we're doing with this experiment. So this is a recreation noise study. Here's some of the images from just, when we initially deployed camera traps on the Bridger-Teton to understand where are there mammal hotspots that are not on recreation trails. These are kind of animal trails that we found in the springtime. The ones that had the most, mammal activity is where we targeted and set up our experimental arrays. And so what these look like are, they're using this new tool that can be integrated with camera traps called a boombox. And here's a recent paper describing this. And what you're seeing here, and I'll highlight it, that's actually speakers in the tree. And we were able to play back recreation sounds as animals move through the landscape and record their behavioral responses. And this is based off of, a pretty big paper that was done a while ago for birds, looking at this phantom road experiment, where basically birds responded just as strongly to areas of where highway noises were played in a regular forest versus an actual highway. So the impact of the highway wasn't the visual of the highway or even the change in structure. It was actually the noise caused the same amount of impacts or degradation in habitat for several bird species, whether or not there was an actual highway or just the noise itself. So the purpose of this experiment is to really, I'll now show you an example of what the experimental setup looks like. It's to better understand the sensitivity to recreation noise among different species, and to understand, can they, habituate to some of it, and, different types of recreation sounds, and do we get at, certain, and the intensity of recreation. So what we did is we recorded people on the landscape recreating, and we recorded different group sizes. So for example, 2 people mountain biking and talking, 2 people mountain biking downhill and not talking. So all sorts of variations of recreation sounds, and played them back in our setups. And these setups look something like this. We actually have 4 trail cameras per array. And what happens is, as an animal comes into our array, we have 2 cameras pointed outward in one direction and 2 pointed the other direction. This first one is associated with that boombox that I mentioned. So the animal comes in, there's no noise being played or anything like that, but this first one trips the boombox, so that when the animal triggers the camera trap, noise begins to play from 20 meters down the trail. We are then still recording behavior there, and we're recording it further down the trail. So we're able to see, does the animal continue down the trail as if, no big deal? Do they turn around? Do they flee? And we can also look at changes in mammal assembly through time as these different noises get played in these locations. And various forms of behavioral responses, and just simply occurrence or not in these locations. There you can see it continuing on. And we did a test, a test year this first year, we a pilot season, and we only used noises for mountain bikers, hikers, and also some null, where we didn't play anything at all. So we're trying to avoid some sort of startle response. But we also did ones where we played nature noises as well, as another form of a null, to see, is it just because there's speakers playing some sort of noise, or is it because there's actual humans, and does their voices matter? Does the type of recreation matter? Does the number of individuals in the sound that we play, the group size matter? All of these questions, and this is ongoing research, but show you a couple examples. I'm going to walk you through what one array setup looks like here. So here's a video I made as I walked through the setup. So there's the first camera, and there's the boom box attached to the top of it. And as the animal walks by this game trail, it triggers the sound, which is now technically starting to play. And you should hear an example here in a second. So there's the second camera, and here's the speakers. And what you're going to hear are 2 people biking and talking. I'm the one that caused this to happen by walking past that. And then the whole thing is essentially mirrored on the other side of the game trail as well. So there's really nothing new to show you here, although there's the other camera, the middle one that also plays, and then the final one down here. This is the one that triggers it if animal comes from the other direction. So there's another boom box. All right, so some of the example responses we've seen. So here's the outer camera. We see a black bear approaching our array down the game trail, walking casually. That's his approach on the outer cameras. Here's what the inner camera saw once the noise started to play. He sprinted off the trail as we played the sounds of people walking and talking in this instance, people talking in the background. But we see a lot of varied responses. It's not all just fleeing and terror from recreation. Here's a deer approaching. This is the outer camera. So the noise isn't playing yet. He walks past the camera. And I'm going to skip ahead a second because this is kind of a long video. And what you'll see is the noise is now triggered. The noise starts to play. The animal doesn't flee, but it definitely turns around as it begins to notice the human noises, turns around and walks back the trail at which it came back up, and it actually hangs out maybe like 40, 50 yards back in the forest and sort of listens and tries to understand what the heck's going on there. And then finally, we have some animals that just don't care. Here you're going to hear the noise of recreation being played, and the moose has just walked right on by. absolutely has not changed its trajectory or its movement. And in fact, it actually stops and checks out our last camera and clearly is communicating by our recreation sound. So the idea is, you have to get a lot of encounters, but this is a lot of other studies have relied on really observational data to understand the impacts of recreation. Here we're actually experimentally applying different types of recreation with different intensities. And so the final piece to this that I'll mention before I wrap up is that in addition to that mammal camera trap work, we're also doing something similar with acoustic monitoring and bird communities. So here's what the setup looks like for the birds, in that we have these bioacoustic monitors that will record bird song for 20 minutes at the start of every hour for daylight hours. And what we do is we play those same recreation noises that you heard for the mammals, but we play them for the birds, and we play it 10 minutes into every recording interval. And we're able to see, do we see a change in species composition, a change in calling intensity of different species? So here's an example. Over the course of 2 weeks at one of those sites, we see the different species on the left, and we see the time, the 20-minute recording interval across times of day. There's just an example here. And we see every point represents a call from a given species. And we're able to do this. We're able to classify all of these relatively quickly using various AI software, because otherwise there'd be, thousands of hours of listening, and differentiating all the different calls is, rather tedious. So we're able to do this, and the idea is we'll be able to start to analyze the pre, during, and post recreation noise impact in these locations. All right, and finally, to kind of wrap things up here, so how do all of these things jive together? How do we hope to improve management on the Bridger-Teton and beyond in terms of thinking about the intersection of recreation and wildlife? Well, we talked about the modeled sound cell data, and then these two new experimental approaches for wildlife and bird sensitivity to recreation. But what's really nice is that those same bird bioacoustic monitors can also be deployed to not only capture bird, but also capture human noises, anthropogenic noises on the landscape. So you can essentially hit two birds with one stone, pun intended, whereby you're getting at bird communities, but you're also then capturing noise. And the idea behind that is we're able to then start to assess and improve some of those predictions of noise on the landscape through actual collecting of sound on the landscape and collecting bird calls for other aspects of it. But in addition, we can improve those predictions of noise, as we combine it with real on-the-ground measurements from our bioacoustic monitors with our cell phone data, because now we know the temporal dynamics, and we know really the intensity in one place versus another. We can begin to improve some of those modeled sound estimates that incorporate things like terrain and vegetation and distance to other things, so that we're able to capture a near real-time, much better prediction of anthropogenic noise and really impacts on wildlife and also the visitor experience as well. And finally, by having those better predictions and better maps then through those pieces, and understanding at a much better level the sensitivity of different wildlife species, we're then able to overlay all those and understand where are the likely spots where it may be degrading wildlife, bird habitat for the most sensitive species in the areas where we've seen the most rapid change or increase in noise and recreation use and different types of recreation, to better protect those areas and or manage those spots more appropriately. And with that, I think that's all I have for you. I appreciate it. You having me here today. I'll happily take some questions, and yeah, thank you so much.
Thank you. I see some that are comments, and I don't know if you want me to go through the chat for you and read it out to you, or if you want to read it.
If you want to pick whatever ones you want, we would prefer me to go to. I don't even have the chat open yet.
Okay, that's okay. One person said that some of this work could be interesting to compare and discuss with scientists such as Susie Sitter. As a part of her dissertation work, she's worked to apply movement ecology and movement models to recreation GPS paths in a few national parks. And Valerie asked, is it possible to add links to these publications in the chat?
Oh, unfortunately, none of this is published yet. The cell data, again, and that's just example data that we've been working with to kind of understand what all is possible. And we are in our pilot seasons, finished up our pilot season for the recreation noise on birds and wildlife. So we're just kind of beginning the process of analyzing that data. So unfortunately, there's nothing to share there, although I'm happy to share, if people are interested, some of the sensory ecology, sensory pollution interactions with wildlife stuff that either I've done or others have done. Like I mentioned, that the bird study by Jesse Barber at Boise State, he's also involved in some of this work. I've done some work with the influences of artificial light on predator-prey interactions and urban wildland interfaces. Oh yeah, no worries. But those would all be, if someone's interested, feel free to reach out, email me, mark.dittmer@usda.gov.
Another person said, I can see this being super helpful to some of our wildlife management areas where we're trying to allow non-hunting fishing recreation, as long as it doesn't significantly impact wildlife. Any ballpark costs? And I know it depends on area. Are we talking hundreds, thousands, tens of thousands, or more? Just kind of, is there a ballpark figure?
So that's really hard because of the different companies have been very different in terms of their willingness to do data for good. And so we tried to purchase it and kind of ran out of timing this past year, and we were looking at a ballpark that was over 100,000 for the data. But as we open it up to more of a competition for the contract, maybe we'll see lower costs from some of the companies that might come in. So it's really something I can't give you a super straightforward answer on.
I think just knowing it's over 100,000 is good, because it puts it in kind of a ballpark to understand. And they said, can you share the company that you use to provide the cell data? I guess that's that preliminary sample month data that you got.
Yeah, that company is Veriset. And I would say that a lot of these companies, they exist to work with more corporate partners in terms of like when you say you put in your Google search engine, you look up a restaurant, it tells you how busy is this place. It tells you basically in real time. Well, it's using the same data. So big companies like Google also purchase this sort of data to provide that sort of instantaneous, where are people in time and space information. So you have to really find a good partner that's willing to potentially do at a lower, at the data for good thing, because otherwise I don't think that, we're going to be able to get a contract similar to, say, what Microsoft might have to pay to run their Bing engine or something like that.
That's all the questions I saw in the chat. I see a lot of, this is fascinating, this is very interesting, thank you. Any other questions? I did provide a link to where the recording will be posted once it's ready. I put a link to Veriset just because I was able to find it quickly. Any other questions? All right. I think we're good.
Great, thank you.
This was amazing. And my geographic heart loved watching all of this and seeing all the overlays. So I can see a lot of utility in this. So thank you all, and hope to see you at next month's webinar on is a scavenger hunt in Florida. So we'll talk soon. Thanks.
Thank you. This was terrific.